how does an AI model learn? Well, it turns out it's actually pretty straightforward, even though math language will obscure it with the terms like coefficients and epsilon. All these fun math words, guess what? They do help not much, right? They kind of make it a little more complicated than it really is. But it turns out AI is actually pretty straightforward. It's just a set of numbers, right? And one of the YouTube questions that we had here was, when you're creating an array of numbers, what do you initialize those numbers to? Now, you could initialize all those numbers to 0, though that kind of throws away a lot of the initial training. It's not really necessary. It will work, but usually what we tend to do in the industry is randomize the values. So here are the neurons. The neurons are just numbers, right? Floating point numbers, float 32, so 32 bits in the number. And that means that every single one of these neurons can be billions of possibilities. That's in just one number, right? And so if you combine all these numbers together, you get essentially what AI can be, right? You get hundreds of trillions and trillions and trillions of possible combinations that this AI can sort of learn through just a set of numbers. And so the very first step training an AI is, you got to create a bunch of numbers, so that way the model has something like a foundation to start from. The first step to training an AI. Oh, also, just in case if you didn't know, neurons are just another word for weights, the model weights, or the parameters, right? Or the coefficients. These are all essentially the same meaning, and they are essentially just a number that looks like this: 0.3, 0.4, right? Or -1245. These are just simple numbers. When we're training an AI model, the first step that you have to do is see how inaccurate the model is. That's the whole part of how you train the model. Stage 1 is you ask a question to the model, and the model will give you an answer, right? And so what you do is you take that answer, and then you will actually have in your training data set the real answer, and then you see how far off, right? So in this next stage, when you're training a model, you just have to ask the question. The question asking part is called forward propagation. This is the prediction aspect. So it's where you feed your input data, which is your question essentially, to the model. You ask it the question, the input data, and then you feed it forward in the neural network. And then matrix multiplications occur along with several other math functions. And it kind of looks like this. We get there the input layer, which is your question. And then you've got your neurons, right? And your neurons are going to look like this. You've got weights, your parameters, your coefficients. They're just floating point numbers. And then you have an output layer, which is going to be in the same matrix shape that has all your possible answers, right? And so say if you have an answer, if there's a cat in the photo, right? So then your output could be like, output layer would be like two neurons, for example, right? How likely there is a cat in the photo and how unlikely there is a cat in the photo, and you can sort of resolve that later. Or you can have one neuron that it ranges from 0 to 1, and you can train it on that. It's like there's 100% likelihood that there's a cat in the photo, or 0% likelihood. So it's kind of up to you on how you train the model. They'll both do the same, essentially. And if you want to do deep learning, you can have multiple layers. So layer 1, layer 2, layer 3 here in the middle, and it starts off with your input, and then it just waves out into your output. And that's the forward pass. This is the forward pass part, where the model will give you an answer, right? So you ask it a question, it gives you an answer. And now we have the data, we have the answer from the model, and then we can sort of teach it from there. When we're teaching an AI to learn, it's kind of a similar setup to where you have a student and a teacher. The teacher will have all the questions and answers, and the student is the AI model. And the AI model will have none of the input, it has no idea what the answers are. Instead of the teacher sort of going over course material first, actually happens is in traditional AI and machine learning, the teacher will just immediately start off with a test, right? They'll test the AI model to see, will you get this answer right? Will you get this answer right? And at the very beginning, because the AI model knows nothing, you'll get wrong answers always. And so from the teaching and the learning perspective, we need to see how far off the AI model is from its prediction. So we calculate that with the error, the loss, how far off the model is. So say we know what the actual answer is. We say, what is 2 plus 3, for example, right? That would be the question. The answer is 5. The model comes back with 3. And so what we're able to do is calculate the error, how far off, right, the delta is from the actual answer and the predicted answer. And then we take that error, which is off by 2, and then we go on to the next phase, where we update all the weights in the model here will change ever so slightly based on the learning rate. Now we're talking about backward propagation, which is the opposite of forward propagation. The idea with forward propagation is being able to ask a question to the AI and then you get an answer as the output. Back propagation is we already have the answer that the model gave us and we calculated the error, right? How far off the model was. So you do a simple calculation of the error. The actual answer is 5. The model predicted 3, so the delta is 2, right? It was off by, because 5 minus 3 is 2. So we can take that error, and then back propagation is the process of taking that 2 and then reversing it through the AI model's weights, the parameters, the coefficients, the neurons, calculating a gradient. And now the idea of a gradient is just an array of errors that can be applied to the weights later down the line when we optimize, right? When we teach the model. The final stage, when we teach the model. As we're moving backward in the model, through the layers, we calculate gradients. Now, right, these are just arrays of corrections that are representing the error correction. So we will be able to, in order to get the model to correctly predict 5, which is the right answer in this case, we will update all of the numbers here in our brain, right? The neurons. We will update the numbers in a certain amount to make sure that when next time we ask this question, the model will get it right. Now, you could ignore the idea of learning rate, right? Which is just applying a fraction of the error to the weights, right? So instead of fully correcting the model, so that way it can immediately, with just one set of adjustments, get the answer correct, we won't do that in this case, because what we want to do instead is just slightly make adjustments to each of the weights in the model. Each neuron will get slightly adjusted. This is, a nice, smoother way to teach the model, and it's necessary because we want to teach the model more than one thing. We want to say, we want to be able to ask it a whole bunch of math questions, not just what's 2 plus 3, for example, right? In that case, that would be 5. But what if we wanted to ask what 3 plus 3 was? So the model won't know how to deal with that if we always correct the model 100% of the time, because it will start oversubscribing. And this is called overfitting to specific answers. So you want to train the model on as many examples as possible when we're calculating this. And at the end, we'll have a nice array here of possible corrections. And then we move on to the final phase, optimization. We're finally there. We're at the point where we can train the AI. We know we have all the data that we need to be able to teach the AI what it needs to know. And it turns out it's really simple. Look, we check this out. Look at this right here. This minus sign is teaching the AI. That's right there. Isn't it simple? It's just so surprising. This is the process for actually training. You might have heard of this. It's called updating weights. This is the updating weights, or the optimization phase. So what we've done is we've calculated a gradient. That gradient is calculated by finding the error and then backward propagating through all of our matrices, right? So we've got a whole bunch of numbers here, which are the neurons, to be able to create essentially an array of corrections. So we'll see these model weights here, which is the brain, and then we'll create another array that mirrors, and then we're able to find the delta of error, and then we can subtract that and create a new matrix at the end here. So we'll create a new matrix with weights. So we've got our original model, old, right? Our old model here, calculate our gradient through back propagation, and then we apply a learning rate. We want to do that because we're going to be going over the material multiple times. So we essentially ask the model a question, it gets it wrong, and then we see how wrong it is, and then we look to see how we can correct the AI for every single one of its neurons, and that's the gradient. Then we apply a learning rate, and it's like maybe 1% or less, right, of how off we want to modify it, and then we get a new weight, and then we loop, and we do that again, and we do it again, and we just keep doing that until we have a model that can answer questions, not only the questions that you've shown it, it'll be able to also answer generally questions that it's never seen before and get a high probability of accuracy. And that's the process of updating weights. It's also called optimization. You may have heard those terms with machine learning before. Here's a quick checklist for how an AI model learns, and sort of end to end. What we need to do is make sure to create an initialization of our weights. So we have a bunch of arrays. the weights, or the neurons, right, the parameters of the model, will be floating point numbers. We'll initialize those with random values for every single floating point number. Then we will ask the model a question, right? What is 2 plus 3? The model will give us an answer, and then it will save the output, and then we'll calculate the error. So say the model answers 3, for example, but the answer is actually 5. So what we'll do is we'll subtract our known answer from the model's answer, and then we get what's called the error, right? The delta. We take that delta, and then we back propagate that, which is the opposite of forward propagation, through our array, our matrices, and then we create a gradient, which is just an array of how we will be updating the model weights. Oh, and forgot to mention that forward propagation and back propagation is mostly based on matrix multiplication. So when we're inputting data into the model, that's a matrix of numbers. The input layer of a model is also a matrix, and then all the subsequent layers are also matrix, right? So they're all matrices all the way down the line, all the way to the output ends up being a matrix. So what we do is, in the backward propagation, we will calculate the gradients, and this will be what we need to use to teach the model. In the final phase, we update the weights. We slightly adjust the weights with a learning rate from the gradients. So we just kind of check here really quick. So we've got our array here, which is the brain of the AI, and then the gradient, the same array, but with the corrections in order to correct the model, so that way it gives us the right output next time. And then we apply a learning rate, so that way we can teach it slowly over time as many of our data sets that we have, right? So we give it all the questions, we have all the answers, we train it over time slowly, and then in the future, the idea is it can see a question that it's never run into before during training, and that will give the model the opportunity to answer in a pretty highly accurate output. And so that's the whole idea behind AI. We give it a whole bunch of examples, it learns, and then it has a general purpose, sort of like a general understanding on how to solve those kinds of problems. And so in the future, it can see new things and then give us answers that are pretty close, if not exactly, on target. And so that's it. That's the checklist for how AI learns. Pretty simple, right?